In this video, we're going to look at the very beginnings of functions, typically grade 10 and some of these moving more towards grade 11. And so you've got a summary table here of what's going on. And this is more just to frequent you with the basics in case you want to take a screenshot. And so what you've got is your straight line, which you're probably used to, y equals mx plus c. The m is the gradient, the c is the y-intercept. And there are no asymptotes, so it would roughly look like this. The parabola is y equals ax squared plus bx plus c. And a parabola, you'll notice that it's a parabola because it's got a power of 2. And it will look like a sad or happy face. And it also doesn't have any asymptotes. So the c value, the number at the end for these first two, just represents your y-intercept. And if you needed to work out your turning point, which we'll get to later, but just to whet your appetite, if I needed the turning point now of a parabola, I just use this formula minus b over 2a to get the x value at the turning point. And let's just say I subbed everything in and I got an answer of 4. Then whenever you're missing a letter in functions, it's going to come up so much through all these examples and videos. Whenever you're missing a letter, then just sub in a point. So I'll sub 4 back into the equation for x and it will spit out the y value. So just remember that. Exponential, you'll notice it's an exponential because it's got an exponent of x. It's got an exponent of x. That's how you know it's exponential. And now suddenly the number at the end of the question, the constant, is your asymptote. So for these two, this is your y. Instead of intercept, it's your y asymptote. And there's one of them. So whatever number's here, in this case, that could be 2, for example. You just begin by drawing a dotted line of 2. And then for all of these graphs, if I ever need a y-intercept, I just let x be 0. If I need an x-intercept, I let y be 0. So keep coming back to the basics for all these graphs. And then the last one is the hyperbola. You'll notice that it's a hyperbola because it's over an x value. And what you have here is your q is just your y-asymptote. So here it looks like it's probably minus 1 or 2. And here, your x, if underneath the line it was x plus 3, then think of that as a bracket. So the answer that comes out of there would be minus 3. And so you would have had an asymptote for x as minus 3. So just look out for that little trick. Be careful. I've seen a question asked before like this. And the temptation is to kind of think these are hyperbolas. But actually this one, if I rewrote it differently to make it look more familiar to you, it's just a straight line. There's no number at the end, so the y-intercept is 0. And this is just like half x, so half is just the gradient. Whereas this one, the x is at the bottom. And so the y-asymptote would be 0. And the x-asymptote would be 0, but it is a hyperbola. A hyperbola, you'll always notice, as I've written down here, that you'll have 2 separate arms on the diagonal side. So if it's positive, if this number at the top by a was positive, so if that was positive, it would have been in these quadrants. And if it's negative, then it would be in the 2 quadrants like I've shown. But obviously, as you've drawn your asymptotes, the graph itself will shift to fit perfectly within those 2 asymptotes, as opposed to always religiously being stuck inside the exact quadrant. And so I hope that was helpful just as a basic visual that you can come back to for graphs and which one to choose, how to recognize which graph you're dealing with, the basics of getting x and y intercepts and how many asymptotes it has. And if you did, please like it, subscribe to our channel and share this with your friends.